was hoping that Hannes would be here, so I don't have that. I'm gonna pull. It's, you see that? It's different.
Oh, there's
no,
no HTML.
no, it's not HTML.
Okay, so you need
Yeah.
HTML to VGA.
You thought, who cares? We can have something.
Does anybody have a projection adapter which takes HDMI from the cable and gives him VGA? HDMI to VGA?
You know who would are there any technical content can help? about this, guys. I'll stop the sheet here. I don't have that HDMI thing. Oh, should I give it? I have links. This one. Which one? Unless you want to present. Do you have it? You can put it here. You have it? Yeah, I just give you that. You said 2 minutes. It's 10. It's 50. Good length. How many? 10 minutes. No kidding. Yes. Oh shit. See? I thought you started full hour. No. That possible? Yeah, I think it turned off because the most time there. But I'm connected. Could you turn it on? It's like there. Now it works great. Only how much it is. Oh, no problem. Oh. Okay. Hey everybody, sorry for the delay here, some technical difficulties here. So this is the
OAuth here, the work group. And next slide, yeah. This is the note well. If you're not familiar with that, get familiar with it, please. Request. So we have, can we get a Jabber scribe and a minute taker? The volunteers. He's presenting, yeah. Can't you do that at the same time?
Can you take some notes? Thorsten, can you take some notes? Nat, can you take some notes? You've no laptop with you. Can someone join the Java chat so we actually have someone in case someone's relaying some questions? Can someone join the Java chat? Okay. Can you try? Okay. Someone who is already in Java can check whether there's some Java messages. Nobody wants. Come on. Nobody on Java. Can't be true, you know. Leif, are you in Java? Yeah, just checking whether someone has some questions and relay them. Awesome.
I'm on Java.
Okay.
Oh, thank you. But I'm only going one way. I'm going to go room to here. Watch video.
Okay, so status update. The first one is device flow. So this was updated just recently. So the plan is to run it one more time with the workgroup last call, and then hopefully we'll ship it. So that's the plan for this one. Yes. Right. Oh, yes. Okay. Yeah, we will discuss that too, right? The discovery draft, Mike will talk about that in a second too. And that Jwt request here. So what's the latest one? I remember.
Okay, do you know what the status on this one is? On the it's OAuth2 authorization framework JWT secured authorization request called char. Is that ready?
The status is Stephen hosed me. The status is that so this actually got through ISG before I was AD, and I have to figure out why it's still stalled. I think so. My understanding of what happened is that there are a bunch of comments and they got cleared by the and they got cleared by fixing the document. And then I finally went and looked at the document to see how the changes were, if they were substantial, and they were substantial. And so I talked to John this morning, and he said that those have all been run through the working group. So as long as you agree they've been run through the working group, then I'll just review them for craziness, and assuming that they're not crazy, I'll advance the document. So is there any? So I mean, as chair, as chairs, do you guys represent that the changes between the thing that was approved in the current document were run through the working group?
Well, I need to double check because I don't know from the top of my head.
Okay, no problem. So I'll assume it is, and I'll check with you later.
Yeah.
And I'll just review the changes myself for is there anything insane in there? And I'm not reviewing the entire document because obviously the ISG approved it.
Yeah, we can check it right after this meeting to get.
Sounds great. Thank you.
Date.
And yeah, then we should move forward.
Cool. Yeah.
And I feel like the other 14 days probably is still within the margin. Is that 34 days? I'll get to that soon.
Yeah.
Which one? Okay. Yeah, with the exception of the token exchange, right? So I'll talk about that. Okay. Okay. So the rest of them will be presented today, with the exception of the token exchange. So the token exchange is we're currently working on the write-up for that. So hopefully we'll ship it very soon to Ecker for one more document to review. So that's the update.
So for next year, we have already prepared another OAuth security workshop. Here you see the sign-up page. More details on the next slide. This is, as you recall, we have done the previous workshop specifically to reach out to some of the researchers who investigate sort of implementation and sort of formal method analysis techniques or apply them to our protocols. So I think this is really useful effort, but also encourage folks in this community to participate and to share on what they are doing now, so that researchers actually become aware of what items they should be looking at and what status the documents have. So at least in the past workshops, I thought them extremely useful to find out some, or to get a broad overview on what these different techniques are that people apply to analyze protocols. I think which is why we try to organize another one. The date has been chosen as the week before the next IETF meeting. In the next IETF meeting is in London. This workshop is in Trento in Italy. Supposedly a nice place. Here you can also find the link, and the scope is like with the other workshops. So we are trying to see or receive position papers related to OAuth, OpenID Connect, and OAuth related topics, such as, for example, the IoT stuff that uses OAuth and so on. So anything in that category would be great. And implementation experience is welcome, but also if you did some analysis or had gained some other security-related expertise, please submit a position paper. We will remind you to provide something also at the beginning of next year.
Okay, so here's our agenda for today. We're a bit late, but I think we went through that chair's update. And Brian, so the floor is yours.
Pretty short here. You have slides for me?
Yeah, I don't know why it's loading so slowly.
Okay. Oh, wait. You go. All right. Mutual TLS profile for OAuth 2. OAuth 2 is what we do here. So we're going to talk about the mutual TLS profile for it. So let me get into it. Next slide.
Is the mic working?
Can you all hear me all right? Is that better? Okay. So, sorry. There's better. All right. So what is it? What is the mutual TLS profile for OAuth 2? It's sort of two main things. One is defining a mutual TLS client authentication mode to the authorization server. And there's two distinct methods or modes of this. One is PKI based, where you validate the trust chain and certificate presented by the client and check the subject of the certificate. And the other is what we're now calling a self-signed certificate based mode, where basically you disable trust chain validation on the AS and just use the mutual TLS to establish proof of possession of the corresponding private key to the certificate. And then you have the actual full certificate configured as a credential for the client, and just compare those two after the fact. And the other part of the draft is defining a mutual TLS sender constrained access tokens for protected resource access, which another way of saying that is just certificate bound access tokens. So actually binding OAuth access tokens to certificates so they can't be used by anybody else. Next slide, please. So why are we doing this? A couple things. One is that mutual TLS client authentication, which is obviously provides better security characteristics than the shared secret method we have in OAuth normally, is something that's been done by a number of different implementations in practice, but we've never, for years now, we've never written it down as an actual standard. And there's been some pressure from some other communities to have it written down so they can reference it as an actual standard and a common interoperable way of doing it. Mutual TLS sender constrained resource access binds access tokens to the client certificate. This is so they can't be played or replayed by any other entity without the corresponding proof of possession of the private key. There are banks now that need these for server-to-server type API cases, mostly being driven out by new regulations around open banking and so forth. This spec is in its draft form is currently referenced by FAPI, the OpenID Foundation Financial API Working Group, in their read-write security profile as one suitable holder of key mechanism necessary for financial level transactions with OAuth. And it's also referenced in the, I left out the UK part here, but the UK Open Banking API security profile, which is largely a derivative of FAPI, but a little bit different. But the idea being that there are banking use cases that want to deploy this in the near future and need a better than bare type solution for access tokens as well as client authentication. And this the standard provides that, building on top of mutual TLS, which is widely available and functional in the wild today. Next, please. So the first part, how mutual TLS client authentication works. Basically, the TLS connection from the client to the token endpoint or any other direct connection to the authorization server is established with mutual TLS authentication. In the request, the client includes the client ID HTTP request parameter as it would in normally, but it's required in this profile. And the AS uses that to look up the client configuration, and verify that the client certificate presented is the right one for the corresponding client. There's some metadata provided in support of the PKI method, which there's a new authentication method name. So we have the token endpoint authentication methods that you can list for server support and client authentication methods. We're defining a new one here, TLS client auth, to refer to the PKI method. And then there's a new client metadata parameter that specifies the expected subject distinguished name of the client certificate. This is how, when presenting this mutual TLS over this method, the client presents the certificate, the TLS layer verifies the cert chain, and then looks for the expected subject EN in the cert. Would now be a good time, Leif.
Oh, sorry, Leif Johansson. So a quick question. So when we've deployed similar methods in Eduroam, right? One of the things that you actually run into if you do PKI based is you have sort of just looking at the subject EN may not be sufficient for doing good access control. You might actually want to have a combination of subject and issuer, because you may want to do constraints based on, you don't want sort of somebody else to stamp on your name, right? And public PKI is going to allow that if you just do subject EN. So I would suggest that you think a little bit about what you actually want to achieve. Now, this may be enough for the people who want to implement stuff like this, so it probably should be optional or something. But if I were to deploy something like this, I would definitely want something more constrained in my PKI method than just subject distinction.
So in a deployment, you're always free to constrain the set of
Trust routes
that you have, which is one option. In a previous version of this draft, we also had a parameter that allowed you to constrain down based on an issuer DN, so a constrained issuer for the client. There was some feedback from implementers that getting sufficient access to that to actually deploy it was difficult. And following up from the implementer feedback, the reason I'd originally introduced it is we had a similar type piece of functionality as a product feature in our server. And while I agree with you that it's a potentially common and desirable additional constraint to put around it, the idea, or at least the thinking, was that it wasn't necessarily appropriate to be something that the client asserted about itself in client registration metadata, but more something that the server could implement additional constraints as it sees necessary, but not something that should live in the standard itself.
So possibly, at at least I would suggest that getting some sort of security considerations text in there that says, here's some of the stuff that you can get wrong when you do certificate validation, and don't assume that your subject name is unique or can only be issued by a single issuer in your trust set.
Okay. So yeah, that is what is in the current draft. I can look at some additional considerations. There's already some considerations there, but not particularly around that. So it's worth mentioning. And then there's some metadata provided in support of the other method, the other mode, which is the self-signed certificate mode. There's an authentication method name for this as well, self-signed TLS client auth. And then it doesn't define anything new, but references back to the JWKS URI or JWKS client registration parameters from RFC 7591 that already exists. These are ways to specify a set of public keys for individual client. And so the self-signed certificate mode just makes use of these existing client registration possibilities to specify public keys and just references those. Next, please. The other side of it, how the actual sender constrained access works, is on issuance of an access token, the authorization server associates a hash of the certificate with the access token itself, basically binding the access token to that certificate. On TLS connections from the client to the resource server, mutual TLS is needed there. And then the protected resource matches the certificate it received from the client against the hash of the certificate in the access token, and those need to match, otherwise it's an error. That's the binding between the two. In order to facilitate communicating that information, we added a new Jwt Confirmation Method, which is the X509 certificate SHA-256 thumbprint confirmation method. So this is a new confirmation method on RFC 7800, which is just the SHA-256 hash of the certificate included in the CNF claim. And then parallel to that, there's a new confirmation method for token introspection, which is exactly the same data as the JWT confirmation method, but it's returned in the introspection response and checked by the protected resource in the same way. So either way, it's the job of the protected resource to get the certificate presented by the client and compare it to the hash of the certificate in the access token. Maybe one important detail about this is by using the hash of the access token, the actual binding of by using the hash of the certificate in the access token, the actual binding of the certificate to the token doesn't vary based on the client authentication method. So that regardless of the mode that was used on the authorization server, the presentation and validation method is the same at the resource server. And then there's just examples down here at the bottom of the JWT confirmation method of token introspection. Unsurprisingly, they look very similar, except for a little bit of the ceremony around one versus the other. Yeah, Justin.
Justin Richer. So just to be clear here, the certificate that's being hashed is the one that's presented to the token endpoint, right?
Yes.
So this is unable to be used with anything that doesn't call the token endpoint, specifically implicit flow or derivatives thereof.
That's correct.
Okay. So implicit clients can't use certificate bound tokens. That is a current limitation, yes. Okay. Is that something that we're planning to try to patch, or do we want implicit to die? Or what?
We don't think implicit makes sense for this use case because that would be a client certificate in the end user's browser.
In the browser, right. But,
which isn't.
So, yeah, John Bradley. So the experience of mutual TLS for users in the browser is known to be suboptimal, to put it highly optimistically. Encouraging people to get users to provision soft certificates into their browsers to be able to do this would be a nightmare. We believe that token binding and the fetch extensions in the browser are going to provide a much more manageable way for doing proof of possession tokens through implicit flow. So it needs to be addressed, but not using certificates, because we've beaten our heads against this problem for a decade, which it's not going to happen.
Thank you. That is a perfectly reasonable approach. I would just like to ensure that this draft very clearly cuts that out, as this part is not our problem.
It's implied now. I think adding some explicit wording to that end would be useful. Did I finish that? Yeah, I did. So just
a quick question about the previous slide. Is it the hash fingerprint of the subject? Is it the whole thing, right?
The whole thing.
Dear encoded.
Yep.
Yep.
Thorsten, yes.com. Leave one question. There is, coming back to your question regarding the scoping the DN of the certificate to an issuer. We've got some text within the security considerations about X509 certificate spoofing. Have you taken a look into that? Yeah, just a question. Yeah, because I think that's somehow the text you were looking for. So yeah, okay.
It may, I'd forgotten that's in there. It may not be everything you want, but it's a start. So if you have some, take a look and let us know if there could be better or more. Thanks for reminding me, Thorsten. All right, so just a little bit of history on the document. I presented draft 2 in Prague, and I maybe had a little bit premature call for a working group last call at that point. But it led to some excellent discussion and some, I think, really worthwhile changes to the draft since then. So there's been 3 drafts published since then, and we made a few changes, which I'll summarize here. Went from kind of leaving the trust model completely wide open and saying you just have to do something, to clearly defining these 2 methods of client authentication, the PKI method and the self-signed certificate method. It's kind of one or the other, and I think it's a nice improvement to nail down what they are. I wanted to leave it open to allow for either, but really these are the only 2 kind of reasonable possibilities. So it's much tighter now. There was introduction of AS metadata and client registration parameters, which can be used to both request support for mutual TLS sender constrained access tokens and publish your support thereof. Let's see, clarified that the client authentication isn't exclusive to the token endpoint, and that it can be used for other endpoints such as that require client authentication, such as revocation and introspection endpoints. Some of that I think was just legacy and a little copy paste, that in the original world of OAuth, the only place the client could directly authenticate to was the token endpoint. So a lot of the wording sort of carried over for that. But since that time, we've had introspection defined, we've had revocation defined. And so it makes sense to just broaden it. It's really just wording, but that was always the intent. It just didn't read that way. We did remove the client TLS auth root DN client metadata field. This was the one that was at one point intended to allow for the constraint of the issuer on a particular client. But like I said, it sort of fell in the wrong place. Allowing the client itself to specify this didn't necessarily make sense, and it introduced a lot of support requirements that might have been difficult for certain implementations to accommodate. So it didn't feel entirely appropriate. It doesn't mean that a particular AS implementation couldn't do something like this to further constrain their trust, but it didn't make sense in the context of standardized client metadata. And then based on some feedback about just reading through the doc, reorganized it to try to more clearly distinguish between the different moving parts, specifically distinguish between the client authentication method and certificate-bound access tokens. They're very similar, but they're distinct in the document, so split them out better. And then more clearly delineate between the 2 client authentication methods. Those are the changes since Prague, and there have been, so I actually I paid someone to build a bike shed in my yard over the summer. And so, contrary to everything you hear in the IETF, the picking of the colors was pretty easy. I chose some colors. I showed them to my wife. She told me they were wrong and told me what colors to choose. And that's what we went with. It's really pretty straightforward. The only commentary there's been some commentary on the latest draft. One implementer said it looks good. Another one came back and had a bunch of editorial stuff, but the only sort of substantive comment was around the name of the client and server metadata parameter used to indicate support for bound access tokens. That is, it was described as unnatural. The current name is mutual TLS sender constrained access tokens. He proposed certificate bound access tokens as being a little bit more natural. That sounds nice. But you could also go with mutual TLS certificate constrained access tokens, mutual TLS certificate bound access tokens, MTLS certificate bound access tokens, MTLS bound access tokens, TLS client bound access tokens, et cetera, et cetera, et cetera. There's a lot of potential options here. I'm not sure that one is demonstrably better than the other, and opinions are like, fill in the well-known saying if you like. But it was raised. I'd really like to get to some, I don't know. I guess if there's really strong opinions, please bring them to the list and maybe we can drive to some consensus. But this stuff is meant to be machine readable. Humans will look at it, and I'd sort of like to just leave it as is, even if it's not ideal.
This is Justin, and that is a very handsome medium gray.
Thank you. I'll tell my wife.
Tell your wife. But no, I actually did want to expand the scope of the bike shed discussion to the client authentication parameters.
Yes.
Just because they both have client auth in them, and that bothers me because none of the other client auth methods have client auth in the name. And so, yeah, that's like saying that's bike shed gray instead of gray. Gray. So anyway, if that type of discussion is on the table, I'd like to visit that. It's a syntactic change. It's arbitrary. I'm totally with you on that point. But if we can chop those, I would be happier. So
I will say that because of the referencing by some like open banking using this,
right,
they are already making use of at least one of those modes in their documents. Mm-hmm. So changing it now would have ripple effects that I think for the sake of just changing a name like that, I would prefer to avoid.
That's a fair consideration to have. So, okay.
And they're supposed to go live in January, which is which has its own issues, but for the sake of just changing a name based on aesthetics, I'd prefer to avoid it. So, yeah. So I'm leaving it at this. If you have super strong opinions, please raise them. Otherwise, I think leaving it as is probably the best course of action right now. And so next steps, we'll be in London early next year. London right there. And so I guess I'm tentatively saying perhaps we're really ready for working group last call this time. And so you don't have to hear me do the same spiel again.
Thank you, Brian. Brian, a question. So how do you see this document being different from the token binding document?
The words and the title and the document identifier. So to be, if I can be really frank, I've referred to this document at times as sort of like a poor man's token binding. It provides many of the same benefits, at least with respect to binding the access token, that you would get from token binding, but in a way that is deployable now, because the mutual TLS functionality that it relies on exists and can be deployed. I have working prototypes of all this, either in product or extensions in product in the lab.
I would have microphone, if at all. Okay, do you want?
Go ahead.
I wanted to add, because I would have phrased it differently, and I think we should clarify that in the document to explain the relationship. I would have actually said the token binding is about this, the raw use of raw public keys, and this document is the use of certificates. However, unfortunately, as this slide shows, you have also a self-signed certificate mode in there, which makes it awfully similar to the token binding. And so, like, where did that came from? Like, did the banking guys ask for the self-signed certificate, or did they mostly ask for client certificates?
What I've seen them doing, they're looking for more traditional client certificates in a PKI type mode, and they have, to the best of my knowledge, their own sort of PKI for their deployment of it. The self-signed mode came out of sort of opportunistic in that we didn't want to force a single trust model on there, and that it's useful. It provides the ability to do some of this binding that is, in a sense, similar to token binding, but using existing deployable technologies.
No, you don't need to justify to me. It's
Yeah.
just a question of like clarifying in the document to explain the reader, since we have different documents on what does this compare to others and so on and so on. John.
So this document also deals with client authentication, which doesn't really apply to token binding because it's sort of trust on first use. So,
Yeah.
so there is a component of this that you can't do with token binding because it's using the mutual TLS certificates. The other thing is that this introduces a level of certificate and key management that really isn't scalable to mobile devices and web browsers, etc. This is really more, if you have a server to server sort of environment, this you can do now, but it isn't scalable to every device on the planet without having another, key management overlay. So this is sort of for certain use cases. This is not a bad compromise, but for the broader use cases, token binding is going to work better. Token binding also has other privacy protections that are known to not exist with mutual TLS, and that's one of the reasons why we did token binding, that if the server has a certificate, it's going to present the same certificate everywhere. So these are, generally targeted towards server to server implementations. The privacy of the server, it's known, it's got a client ID, it's not really a secret, so correlation isn't an issue. Once you start getting down to user devices, then correlation becomes more of a privacy issue.
This is Thorsten. When we come back to the first slide where you said what this is all about and why we do that, you stated that this is going to replace shared secret for authentication. And I think that's the main reason why we have the self-signed certificates in there, right? It's a very, very reasonable way to replace shared secret for authenticating clients, and you don't need a PKI for that.
It's a lightweight way of introducing public-private key asymmetric authentication.
And that's the main reason why we included the self-signed stuff, because everyone is getting afraid if we mention certificate-based authentication, because everyone has in its head the PKI typically required for that, but that's not needed for client authentication, right? Because you have a pre-established trust relationship between the provider of the client and the authorization server. So that's the main reason. There is no tight binding between the self-cert and the token binding.
So the technical question first is in the self-signed certificate version of this, does the server become aware of the client certificate out of band, or does it become aware of it on first use like in token binding?
Out of band, okay. Either through dynamic registration or manual registration of the client.
Okay. So I guess as AD, I'd like to request that you do make clear somewhere in between these two documents where the applicability situation for each of these is, so that when people read them at the ISG and also when people consume them as RFCs, they can understand when they choose one technology versus the other. That would be very helpful.
Okay.
Descartes, Amazon. As much as I like mutual TLS client authentication, I just want to point out that in the major cloud provider vendors, there are load balancers that do TLS termination. None of them support mutual TLS client auth for passing it down. So anybody deploying this would have to, run their own load balancer and stuff, which is going to be a barrier for people to deploy it and scale. For a bank or something like that, they're probably not going to be sitting behind it. But
you're going to get that changed to Amazon?
if customers ask for it.
Justin, to follow up on Dick's comment, one of the things, a bit of perspective to keep in mind for this work is that in a lot of spaces, the financial industry in particular, they're already doing mutual TLS and then nothing else on top of that. So from their perspective, it's how do we add OAuth to mutual TLS and not how do we add mutual TLS to OAuth. So where today's systems are, you present the right certificate and therefore you can do whatever you want because you got a certificate, you're in the door, we don't care. Adding OAuth to that allows them to have constrained and time limited tokens and scopes and all of this other kind of stuff that OAuth just kind of brings to the party while still having the strong sender constraints that a mutual TLS gives you. So while you're absolutely right, it really doesn't make sense in a lot of cases where you have large scale load balancers and stuff like that. I don't think that's me crackling. It does make sense in cases where you're already doing MTLS and you want to add other stuff to it, more OAuth-y stuff. So I think that's the perspective that people need to keep in mind for this, which is, again, as John was saying, a different perspective from the people who would be looking at token binding as a solution by and large.
So, Leif, you want something
cut the line afterwards.
I got a stupid question about the subject DNs again. I looked at the text. It's sort of okay, actually. But if you're doing, it's better than nothing. But if let's say you're doing what what Justin describes the banks are doing, aren't you doing have an STS somewhere in your architecture and issuing those certificates so dynamically? And wouldn't the subject DN be changing all the time? Do you really want that in metadata? Is that what they're really doing?
Don't think so.
Guys, I cut the line after Leif because we need to move on.
All right.
We can bring
This
that.
was just curiosity on my part. We can talk about it later.
Sorry, I cut the line already because otherwise we can run completely out of time. But please post your comment to the list. Nevertheless, I think you got very good feedback. I see a little bit of clarification also that the comments Justin raised. Leif will double check the document. Who is going to review the document and give us a few names? Justin. Who else? Come on, someone else. And then we'll work with the document also in incorporating these clarifications, and then we are going to issue a working group last call unless there's some major issues that bubble up.
All right.
So expect the working group last call, I would say, beginning of December.
Okay.
I think you're next. Actually.
Back up. Did that really run half an hour? Did that really run half an hour?
Yeah.
Okay. Yes. Maybe this one. All right. Too much. All right. So the related but different topic is OAuth 2 token binding. Usual intro slide. So if we can get to the next one. Just setting a little bit of context here. We adopted this document shortly after Berlin, which is shown here. And really the idea is providing an OAuth 2 based proof of possession mechanism based on token binding work that's happening in another working group here that can defeat replay of lost or stolen tokens. Really all the OAuth tokens, primarily access tokens, but also refresh tokens, authorization codes, and some of the other tokens that are used within the context of OAuth. It turns out there's a lot of them. Next. So just a real quick refresher for what we had in draft 4, which was prior to the most recent set of changes. Token binding of access tokens was defined using the referred token binding ID. as well as a representation in JWT access tokens, how to actually include that using, similar to the last draft, a confirmation method type, which was the hash of the token binding ID inside of a RFC 7800 confirmation method. We also talked about token binding refresh tokens using the provided token binding ID, very similar to what you do to bind cookies. And then there were two modes to allow for token binding of authorization codes built on top of Pixie, one for native app clients and one for web server clients. They're just different in the nature of how they interact, so there are two different ways of doing that. Next. Dependency status included Dallas here because that was when the token binding working group got officially formed, and you can see John up there and Leif chairing that first meeting. The three main token binding working group documents, negotiation, the protocol, and HTTPS, are all very close to RFC publication. I did say something similar in Prague, and yeah, so I was going to say, things move so fast in the IETF that the status has changed since I submitted these slides to the chairs, and today they have moved from submitted to IESG publication to IETF-wide last call, at least two of them, and the third one I think is either out or close behind it. So we are actually moving forward here. Current status of this document is draft 5 was published on October 26 with changes and additions that were discussed in Prague on the mailing list too, but largely agreed upon in the presentation in Prague. And can you scroll up just a little bit or change the, and just for those of you sort of following along at home, the OpenID Connect token bound authentication draft 02, which is very closely related to this, and also itself defines the structure of the confirmation method to carry the token binding ID. That was updated with similar changes to what was in here, which is mostly just around some description of the phasing in and security characteristics. Next. So the actual changes in draft 5, we went and clearly specified that an authorization server should not token bind refresh tokens to a client that doesn't support bound refresh tokens. And that support can be indicated by a client metadata parameter that was already defined, or of course via static or just normal registration and configuration of a client. And then added some security considerations on what it means not to have bound refresh tokens. Mixed into that was a little bit of implementation detail, but it's potentially infeasible for some clients that are implemented as distributed web-based clients on different nodes to actually do token binding in a reasonable way, and noted that refresh tokens are already indirectly bound to the client's credentials. So most refresh tokens are in effect already bound to whatever the client is using for authentication of the token endpoint. So both explain sort of why it might be difficult to bind refresh tokens, as well as why the protections you would get are already in place. Adjusted the language a little bit around aborting authorizations in the phasing and token binding section to be just a little bit more general and not only about downgrades. There was some really specific discussion about detecting downgrade attacks when in case they might actually be just misconfigurations or other potential issues. The suggested outcome is actually the same, but the language is just a little more generalized. And removed a reference and usage of to the OAuth2 protected resource metadata draft, which was an individual draft that is no longer active, no longer a going concern. So we pulled that out of there. Excuse me. Next slide, please. A few more changes in draft 5. So added added or described how you would do token binding for Jwt authorization grants and Jwt client authentication. Brought this up at the last one. You know, for some people it might be sort of self-evident how this would happen, but wanted to be explicit about it in the draft. And really it boils down to the Jwt itself must contain the same confirmation claim with the token binding hash member, and it should identify the provided token binding being used by the client on the connection to the authorization server. Define a new client assertion type, clearly delineating that this is not a bearer client authentication assertion, but a token bound one. And then defined also new authentication method values. Scroll for me just a bit. So these are parallel to the two that exist now for Jwt client authentication, but with token bound in them, the private key variant for asymmetric versions and the client secret token bound JWT for the one using the client secret. And then also define a new grant type to, again, explicitly say that this is a token bound Jwt for authorization grant versus the bearer version. So that's it for that. So next slide. And looking ahead to London, the token binding documents are going to progress to RFC status. And I think it's for real this time. I think that'll happen before we're in London. We're still looking to get implementation experience and feedback here. I will go so far as to say I've been working a little bit on the client side of doing some of this in the early stages, and it's kind of a pain in the ass. So I think it'll be good to as things get standardized and maybe APIs and support develop. Hopefully that'll get easier. But my sense is this stuff is still pretty early relative to what's available in terms of implementation. So some time's necessary here to get some feedback, and then get us all back together and do this again in London for IETF 101. And with that,
thank you, Brian.
Questions or comments?
Questions? Any reviewers? Mike? Why not again? Might be good implementation experience to share at the workshop. Good pictures there as well.
It's hard to get away from the family for
pictures.
For that amount of time.
Okay.
All right. Thank you.
Good afternoon. I'm Mike Jones from Microsoft, and I intend to give you a very brief update on where we are with the authorization server metadata document. Next slide. So our current draft is 07. That incorporated clarifications which Eric requested about some defaults and statements about when you must use TLS, which we'd forgotten to include. So all good stuff. We requested publication. We got back the usual reviews from Opster, Sector, and GenArt. 2 of the 3 said good to go. Another requested an RFC number update, which is correct. And then, actually, I had a very interesting interaction with Mark Nottingham in his role as designated expert for registering the well-known value. And he pointed out a few ways in which the context that most of us who are familiar with the space already understood about when and why you would use this, where it wasn't actually in the document. And so that's, you get fresh eyes on something, and that's always good. So there's a few things which I plan to add with the co-editors, just clarifying the context of like when you use an issuer versus the well-known path, and all good. So within a couple days, I plan to get 08 out that mainly includes the clarifications which Mark usefully suggested. And at that point, I think we'll be ready for the telechat, assuming Eric concurs.
Yeah, that seems fine. Just FYI, we're now looking pretty far out in the telechat agenda, so I think it's probably going to be a month and a half before it shows up. But
how far?
I'm guessing about a month and a half. I'm just looking at the.
Okay, that's fine.
But that's just mechanical.
Yeah, we'll just stay on it.
Okay, thank you.
Thank you, Eric.
I'm the shepherd, and I was. It looks like I have. Did I provide the shepherd right up?
You did.
Okay.
Okay. That's all my slides on this. I just wanted you all to know that we are in process of pulling this through the
ship another
pipeline.
update. It's on the delegate in
Yeah.
1.5 months, and everything is fine.
I believe everything's fine. Next presentation, please.
This one?
Yep. So this is largely another status update, but this one has a call for action at the end. As you know, Kathleen and others requested that a best current practices document be written for the use of the JSON Web Token. And several of us put together a first draft. Next slide, please. There we go. Yaron Sheffer, Dick Hart, and I, with some input from many of the rest of you, wrote a first draft. We updated the 00 individual draft to 01 to include some things about how to better identify conflicts. A decision was made in Prague to adopt this as a working group draft, and we did so forthwith. Next slide. However, since IETF 99, 4 months ago, there's been exactly zero discussion of the draft as far as I can tell, despite the deck asking for reviewers. And, you know, we're all busy doing other important things, but if we care about this, in the end, we do have to give it some bandwidth. I'm not proposing an interpretation of what the silence means. I'm just pointing out there has been total silence for 4 months. Next. What I won't do here is repeat my presentation from last time, where we talked about what we're trying to achieve, how we're trying to achieve it, the structure of the document, etc. All of that's in the record from IETF 99, and if you'd like to refresh yourselves on why and what and how, that's already recorded. Next. This is my last slide about the Jwt BCP. This is the call for action. I think to progress this, we need some people to put eyes on it and put pen to paper about what they saw. And I'm hoping we can find victims or volunteers, depending upon your nomenclature, to do so. And Brian's at the microphone.
Yeah, Brian Campbell with Ping. So I did. There has been some stuff on the list, including I asked about whether and if other ways of disambiguating was considered or useful, which sort of I don't have a strong preference, but there was at least a request to add. Was it more consideration or more clarify where, in fact, if you had a nested Jwt, where you would need to look for the content type that was, or the type for disambiguation. And so I don't think that's happened. And I did.
I do remember that. Could you refresh that note to the list? I may have been searching for the wrong things.
I will try to find it and look for it. And then it's not easily addressed, but I had a question about whether and if the document should cover use of compression in Jwts, which sort of didn't end up anywhere. But I guess it's not entirely fair to say there's been no discussion on it. There has been a little.
Okay, I was just time boxing it from July to here.
I think it's all been since then.
Okay,
but
then I stand corrected.
But yeah, more is probably useful.
But in any case,
I'll try to dig those up.
I think it's obvious to ask for reviewers. I saw Phil's hand going up, unless you are stretching, which you actually do. But Phil, someone else? Like maybe someone with a, I think it's a little crypto heavier, that type of document. Mike, is that correct?
There are discussions in aspects of it of ways that you can get the crypto implementation wrong. So, if we could get, I don't know, a Jim Schott or a John Bradley or somebody as victims, that would be fine, but they obviously have to volunteer.
Yeah, or maybe we could ask during the SAG meeting to have someone.
That's
review
true.
something.
In SAG,
Maybe.
if you could go to the mic and ask for volunteers, a Rich Saltz, or there's a lot of people in that room that could do a good job.
Yep.
I think John is volunteering, no?
John looks hurt.
Yeah.
Thanks, John.
Someone else? Like the JWT is a mechanism that is has usefulness beyond even OAuth, so it would be good to pay you a beer. How's that?
I'd try to throw it at Jeff Hodges, but I have other things for him to do.
Okay, I would try it in a SAG group, but yeah.
Thank you. That's all I had to say. Thank you, guys.
John, you had no slides, right? But you need to send that. Oh, it's just a document. Okay.
Oh, yeah, that's not going to work. Oh, you have an adapter?
wait a minute. Yes, I
Adapter? Right. Yeah. Yeah, there you go.
There we go. This will work. Okay, so is William online? I can't see the mute you thing.
I can't get you from here either.
He's probably sleeping. So we went over the device flow at the last meeting and got some feedback, which we've now incorporated into the draft. So if we go through here, looking at the changes, it's not large sections. So there was the big discussion at the last IETF was around including the code as part of the verification URI. So we split that out. So there's now a verification URI complete that includes the user code, which is separate from the other components. We've added that in the examples. Added some explanation and some wonderful ASCII art. That's William's version of an ASCII art QR code, which he was very proud of. You do what you can. So we added some stuff about polling intervals, another section on session spying. And that's pretty much it.
John,
Yeah.
one question. I saw, Nat, that you had some comments, and one of them was a question about the type of devices that we envision, and I wonder whether all of your comments have been addressed. You think so? Oh, you look at it. Okay.
Okay, that's pretty much it for that draft. So the authors would like to, so we've already been through one last call. If we can do another short last call and catch anything, remaining things that Nat might have or others.
Yeah, that's the plan. So if not, you can take a look and if, yeah. Okay.
So I guess we could probably issue a working group last call already next week.
I would be perfectly fine with that.
It would be great if we knew that someone could also then review that. Is someone of you who hasn't had a chance to look at the document yet, who could take a quick look at it?
Okay, so that's it for that draft. And just so that everybody knows, the other draft that William and I were working on is now actually an RFC. Yay, App Auth BCP is done, which means that we now have to start the next version because the darn operating system vendors have updated things. I guess that's life in the world of BCPs. We have a new draft that we've been working on, started about a year and a half ago. Since then, we've added Carl McGinnis as one of the authors from Okta. So we have, oops. Oh, cool. Okay, don't hold it upside down. So one of the problems that we have with OAuth is that in general, the authorization server has no frickin' idea what application is actually making the, is the client really the client that it claims to be? So especially for native applications, given that they don't actually have client secrets, knowing that you're talking to the right application is a significant problem. I believe Google has seen instances of fake applications. A lot of times people design APIs badly, and given that if you can get somebody to log in with if you log in with a fake client, you can abuse the API to get at other people's information and stuff, bad things like I think Snapchat had a oopsie, which was particularly bad for them, and others. So we started looking at, rather than EMMs, which sort of take a top-down approach, how do we start looking at managing applications from the bottom up? So having applications pass attestations and statements about what their operating environment is to the token endpoint, to the authorization endpoint as a hint, and further from the authorization server to the identity provider, so that if you have an app that's going to a SaaS provider, you may have device posture information that gets presented to the SaaS provider, who then passes that along to wherever it's doing federated identity from, so that the identity provider has some ability to say, wait a minute, that device doesn't have a screen lock, or I don't like that particular application instance to talk to that third-party API. So try to move some of the decision-making closer to the people that actually have a handle on it, getting SaaS providers to make those policy decisions while we have SCIM for pushing policy down to the SaaS providers. It's not an easy fit to make them responsible for making all of those decisions. So in this model, the hints get passed up all the way to the identity provider, but the actual confirmation of whether or not the application is the app it says it is, and the other things that can be directly attested, need to happen on the direct communication to the token endpoint. So policy decisions are made and then enforced at the SaaS provider. So that's essentially what we're up to in this app. So we're adding a couple of parameters and dictionaries for the JSON object. So we have, device vendor, device OS, whether or not it has screen lock, root privileges. These are all things that the app already has access to. So it's not new privileges for the app, but things that if you can determine whether or not it's your app, then the app itself can say whether or not there's a screen lock, etc. You don't necessarily need to rely on an EMM for that. So the first step is, are you the app I think you are? And if you are my app and you're running in a non-rooted environment, then perhaps I can trust some of the other things that you say about yourself. Tony has the look on his face like he had bad fish.
Sean, how do you, maybe it's in a document somewhere, but you're making a number of assumptions here. So specifically with the diagram that you had shown below, where you pass along these parameters, who creates those parameters or this set of parameters, and how do you protect them from not getting modified by the app that claims whatever it does?
How do you... So they're passed on a direct connection. So the ultimate verification happens to the token endpoint. So that's a direct TLS connection to the token endpoint from the application. And for certain kinds of attestation types, we want to use the token binding, so that you can't have the attestations replayed.
So if you scroll down a little bit, then we see sort of the attestation information, and it while this example doesn't show any sort of signature around it, is there a signature?
Right. So the attestations have signatures.
Okay.
So you don't necessarily need to wrap the whole thing in a signature, given that it's going over an authenticated direct TLS connection. But that's right now it's it's not a working group document, so that's where we want to progress it to, so that we can start getting other people's feedback. So it's unclear that we need an extra level of signature around it, given that the individual attestations are signed probably by the operating system, and it's going over an authenticated connection. So one of the tricks and one of the things that's been holding us up is token binding, which is sort of the obvious thing that you can use as a nonce challenge to these various attestations produced by the operating system, so that you know that because the private key of the token binding is never disclosed outside of the device, you know that only the device that contains the private key was able to generate that attestation.
Do we have any comments or questions? Probably more questions.
Sure, Wendy Seltzer. Just looking at the document, curious whether not to see any privacy considerations, and the consideration might well be this is used in an enterprise context when users have no privacy expectations, but some of those indicators might be things over which users might expect some privacy.
That's stuff that we should probably look at, but all of this is information that the apps already have about themselves. What we're doing is standardizing how that gets passed along. We're not actually giving apps any more information. These are all existing APIs on the devices. Yes.
David, as it relates to the these little signed bundles, you said, the attestation is signed by but no outer signature of how it's used is by the application is signed by any trusted authority. So what prevents one application from sort of stealing a little attestation out of memory from another one and using it itself?
But just writing it up.
There's nothing that overall signs that says, yes, this, I don't know. I was just trying to, that was where I was going with the concern about this. It's signed by the operating system, but now it's just kind of a free-floating thing that anyone can use. It's lying in memory.
Well, it depends on the API that those attestations are provided over. So there's on Android, there's something called Safety Net. There's a new in Android O. There's a new Android attestation type, and those specifically say what's the public key of the app that requested this. So it binds the requesting app's identity into that. And Microsoft has some new attestation stuff that they were telling me about last week. Attestations on iOS are probably the weakest at the moment. Well, there is one, but it sucks. But
okay, I didn't want this to be a new kind of bearer token debate. You know, that this little app has this signed attestation. Well, I can steal it and use it.
Right. So in general, the application that asks for the attestation has its identity in that, and there's a nonce that can be that generally goes in that gets signed over. So one of the ways that we want to prevent those tokens from being reused is by using the token binding ID, which again binds it to that particular device.
Yeah, it's to me sounds like we need.
So yes, Tony, you could send a challenge to the device and have that, but again, you can man in the middle of the challenge because of other things. So there are advantages to sending a challenge and having it signed versus using the token binding ID. You may want to do both, but right at the moment, OAuth doesn't provide a challenge from the token endpoint. So these are things that we'll have to, this is the first couple of drafts. So these are things that we can get some implementation experience for. This is still fairly early days.
Yeah, I think the implementation experience would be interesting.
Right, and we have managed to get Okta to actually participate in an IETF working group. Carl may be online. So try to broaden our participation a bit.
Awesome.
The new author.
Mm-hmm. Great.
So we would like to call for working group adoption on that one.
Yeah, let me see on how many of you have read the document. Raise your hand if you read that document or the earlier version. Was that waving at us, Brian, or what? Okay. I think we would have to find some people to review it, but just to get a sense of what, like a sense of the room on whether you find in general the topic, despite on what the current status is. Do you find it useful to have sort of an attestation mechanism for OAuth? Is that something you find worthwhile to spend some time on in the future? Raise your hand if you do. 3, I see more. 1, 2, 3, 4, 5, 6, 7. Yeah. We may not quite be there ready for pushing the button to RFC publication, but I think there's at least some interest. Who is heavily, or who is objecting against looking at this at all? But you raised your hand.
No.
Oh, you have a question?
Yes.
Okay.
Tony Nadlin. This in, yeah, that's good. Thanks. We also over in token binding, Gary has written an attestation proposal for token binding, and I believe it's got some parallelness to what John, I haven't read John's latest, so I can't say for sure, but it sure looks like it, that there's some parallelism between the two.
So in principle, the parts of it could be similar, but this allows the information to be passed from the AS up to the authorization, the authentication server. It allows for additional parameter, a dictionary to provide it, pass additional parameters. So this is more at the application space as opposed to the TLS layer where the token binding attestations might live.
So what's the status of the token binding attestation document?
It's not been accepted yet.
Okay.
There's still, same situation here, people haven't read it.
Right.
Yeah, because I think, like, I looked at it, and because I was curious, and it essentially just defined a field to carry an attestation. It's
Right.
like contains even less content than
Yes.
John's document.
So, John, what do you expect? What do you expect to happen with the attestation when it's received?
Depends on what the attestation is, but you know,
Are you just saying it's going to be unspecified in this particular?
right. We're not constraining what, you know, what the AS is necessarily going to do with that. But if you had an attestation about what the developer key and the app ID of the app that's claiming to be a particular client ID, then the AS would then have the ability to say, wait a minute, that's not the developer key that belongs to that client ID, or some such policy decisions. So the first step is figuring out whether or not the app is lying to you about its identity. And then after that, potentially some of this other information might be useful, but you know, the app developer probably has some relationship with the AS. So we don't want to be overly specific, but you know, having a standard parameter to pass this information along is, I think, a good good part of it. We also have to look at, you know, if the authentication server makes a policy decision based on some of the information, it can always lie, because the app can lie on the redirect to the authentication server, unless we're also doing something with token binding attestations. So there also has to be a way of feeding that those policy decisions back down to the SaaS provider. Lucy.
So Lucy Lynch, I have not read the document, but in listening to your explanations here, I'm having a hard time pulling apart the reliability of the individual attestations as they're passed, and then the idea of profiling multiple attestations into some kind of policy that you then apply. There's a gap in how that works. Absent a signature around the stuff as a package that I don't understand. Can you talk a little bit about why it is that you would take these as individual pieces and allow some external AS to assemble and enforce a policy without more assurance than that?
Well, more assurance from who is the problem. So the operating system generally tends, or the lower levels, something is creating these attestations. The application is going to bundle them together and send them over an authenticated TLS connection. Does adding an extra layer of signature around that necessarily add anything? That's something that's open to debate.
It would allow you to know that all of the required elements had come from the same source at the same time.
No, it wouldn't.
What
No.
it would give you is, it would-
Because
John,
any
John, the typically what the idea is with this attestation is you have some application with a lower privilege, and then the layer below, which has higher privilege, like the operating
Right.
system or something even more, another software component with more privilege, would then provide some information about what is happening underneath, or what it believes is happening underneath. So in that sense, the TLS, if the TLS tunnel starts at, let's say, at the application or at the operating system or at the browser, then if another layer below, like let's say the hypervisor or trust zone or whatever, provides that attestation, then from that point of view, the endpoints would be different. So there, an additional layer of signing would provide additional information. Of course, if the same party signs it and also uses the TLS tunnel, then that would not provide any additional
Right.
benefits, I guess.
So
I think that's-
again, it's who it's generally the
Where does the info come from?
right, and how does it even have a key to sign, etc.
Exactly.
So, it's something that we can look at. There may be a reason, to sign the bundle in the front channel. But again, signing the bundle in the front channel, you then have a bunch of key management issues. And the question is, are we really getting any real value out of that extra signature?
Yeah. And I think what Lucy is hinting to is she would like to understand the framework, the architecture better, like where does the information come from, and does that provide any additional guarantees besides actually the entity that is potentially lying providing the information by itself? Obviously, that wouldn't provide a lot of additional information. So there are lots of implementation-specific issues that need to be considered.
And a lot of those implementation-specific details relate to the individual attestation mechanisms.
Yeah.
So we'll probably wind up with, an appendix of, how you do it on Windows is going to be different from the two different formats which have on Android, which have slightly different
and we did something
semantics.
Similar with the native apps in some sense. So it's not that it's impossible to do it.
No, it's just this is still relatively early. We haven't dug into all of the issues in all of the different attestation formats, and as
Sounds like a lot of work.
by the time we're finished, there will be
More.
other attestation formats, etc., and ways to manage the keys. Torsten.
Yeah, this is Torsten. I'm having a hard time to understand how this is going to work. Would it be possible to somehow outline the overall architecture? I mean, are you saying there is no overall architecture? It's working diffifferently on every operating system?
There is an overall architecture,
Yes.
but the details look differently. I think what we haven't yet seen is a write down or sort of a description of the overall architecture that Lucy has been asking for, and I think we need to get there in an upcoming version.
Yeah.
That would be great. And another question.
The details of the attestations tend to be operating system and even perhaps chip specific.
Yeah, that's okay. That's understood. And I think the analogy to the native apps BCP is reasonable. Another question: are there existing prototypes or implementations of that? So the whole combination, attestation on the operating system level, and OAuth implementation that uses these postures to make informed authentication decisions.
We've talked about building it, but to this point, without token binding, it's hard to get the guarantees for remote attestations. So,
I don't think we need to have token binding for this. I think
it depends on whether or not you want to be able to trust the attestations.
I personally think it boils down to the architecture and the trust model.
Yeah, I think, but Torsten is right. It would be nice to have some hands-on experience with this, because that's in doing that. Like there would be another hackathon at the next IETF meeting. Would be fun to put something together, like on an Android device, just to see how it works.
Yeah, I believe. Well. Let's see who's in the room. I believe that there is one vendor who happens to have a mobile platform that is doing something like this, but isn't talking about it. So there is some implementation experience, but we need to get them comfortable with actually disclosing what's going on. Not Tony.
Stop talking about me. No, I don't know who that would be. But main question, sorry, this is Dave Robin again. Regardless of whether it's inner signed or outer signed or all those other discussions we've had, I just realized I'm not sure what the signature is. You have an attestation that is signed by the operating system.
Yes.
How does the AS know with what keying material? With what agreement? You've got a signature.
Well, again,
What? How does the AS decide whether he likes that signature or not?
well, that's going to be attestation specific. So
Right,
there's,
but if you have
so Microsoft provides keys for
I-
the root of their
I-
attestations.
yes,
Google does
but
for
if
theirs.
you have if there's some magic key in an OS that says, yes, I am iOS 10 dot whatever, and I am signing this, or I'm Android version whatever, how can it possibly say I've not been rooted? Because
well, that's
a rooted one has access to that private key, and it just makes it up.
no.
It doesn't have access to a trusted root
Right.
private key specific to the piece of hardware. But the AS doesn't know that. Are you asking the AS to have a relationship with a version of an operating system or with a specific piece of hardware? Now,
So again, it's
the only keys that are protected or known to the AS would be what? How do I, if I've never talked to this device before?
We need to go to specific examples of attestation. So let's
Yes.
talk about Safety Net, which is on most Android devices.
Right.
So that requires secure boot and various
Yes.
Google certification programs. What I can't remember the name of. But you have to have Play services and so on and so forth. So there is a process that happens on the Android phone, which involves some split key signing that goes off to Google servers, which check the phone, which then
Right. Okay.
look at the signing key of the individual application and various other things and produce an attestation. Now, is it a perfect attestation? No, that's why they've just introduced Android attestations,
Right.
which involves even more TPM hardware, etc. So the actual attestations depends on the operating system. You have everything from total crap on iOS to 2 different versions of things on Android, and I don't know how many versions of attestations on Windows. And
Yeah, in Android, it's by the way not DPM. But.
so again, we're going to have to, the actual amount of trust that you have and what information you get signed by who is going to have operating system dependencies, and we're going to have large appendixes to try and explain what you make of these things. So if you look at FIDO attestations, some of those issues are also discussed over there for the various types of attestations that you might get from hardware platforms. So we don't have all the answers. We're trying to start the discussion.
Okay. Thanks, John. It seems that we sort of got through our material faster than we thought, and cutting the line and with the initial presentation actually wasn't necessary. I don't know if the gentleman who I bumped off the queue is actually still here. Is he? Or did he leave already? I don't see. Where is he? I think there was a person from NIST who had a comment. Is it late? Behind you late? No. Maybe gone already. Frustrated. Sorry about that. So are there any other questions? We have another session with a couple of presentations in the second round, but do you guys have any comments, any ideas, anything? Good. Yeah. Blue sheet. Yeah.
Anybody needs